This video will show my modeling process for drawing this U-joint in SketchUp. This was based on a request I had, so I'm going to run through this in real time, and I'm not going to cut any bits out or any of that stuff. We'll just plug away at it. This image is taken from a textbook that was published about 1904. So I suppose this was a U-joint that was used sometime prior to that. Before I get started, I'll just show you window model info units. Meters, display precision set to as high as it'll go. No length snapping. I don't really care about any of the other details here. And even though this is drawn and dimensioned in inches, I'm going to use meters to avoid the tiny face issue. And before I get started, I will create some tags to put on the components as I create them. So I've got the yoke, the shaft, there's a tapered pin, there's the ball, and then I'm going, and then there's the screws, and then there's, I'm going to create some tags for some cutters that I'll use to cut some of the shapes in the yoke. I'm not going to tag other cutters. There are a couple of other places where I'll use them, but I won't tag those. So cutter 1, cutter 2, and cutter 3. Alright, so when we get to those, we'll do that. Now, I'm going to lay out just sort of the general shape profile of the yoke. And by the way, I'm working with the center line through the screws that are positioned horizontally on the red axis. The center line for the screws top and bottom will be on the blue axis, and the center line of the shaft on the green axis. I like to leverage the axis lines when I can instead of just drawing off someplace randomly. These give me a nice fixed reference point. All right, so some of these dimensions we'll start over here. We'll read off of the right side here, and I'm gonna use guidelines for this. So I don't know where to go for the top edge of this just yet, but I'll get there. So the first distance is 9/32, and then there's a quarter. And notice that I can type fractional units here even though I'm working in meters, so I don't have to decimalize my dimensions to draw this thing. That last one was 1 3/16. All right, and it's only coincidental that it lined up here. None of the others did. So now this, the overall width of this thing is 2 1/8. Oh, wait a minute, before we draw that, let's go back here. That's 2 1/8 this way. 2 1/8. So now I know where that end is there. So I'm going to come over here 1 1/16 because that's the radius, and then I'm just going to come down here a little ways. At the bottom, I'm going to come in here. So it's 1 7/16, so that's 16/16 plus 7/16 is 23. So we'll make it 23/32. That'll give us our radius. And then there's this 1 1/16 radius here, and the 1 1/16 radius up here. So let's do this one first. So I'm going to put a guide point at 1 1/16 from the end point of that line I just drew there. And then I'll use the arc tool and come out here. And I'm going to go through like 35 degrees. I think that's probably going to be enough to get us what we want here. Now, this next center point was on that, 9/32 plus a quarter, so that's here. And of course, I don't even have to worry about the radius. And then we'll come through 35 degrees again. So they just overlap, and that's great. Now, I'm going to use a plugin to figure out where to put the tangent line, but before I do that, I'm going to draw the hole that the small diameter of the shaft fits through. That's 3/4 of an inch. So I'm going to come over here 3/8 and find that end point, and I'll just draw all the way up. All right. Now, we don't need that little overrun there. In fact, we don't want that little overrun. I'm going to select these two arcs and use tangent tools. There it is, common tangents. And then I'll use the line tool. I'm going to zoom way in here. And the actual tangent point is up here. And I could do a couple of different things here. I could replace my arcs with ones that end. In fact, let's do that. Let's delete both of those arcs. And I'll draw them in again. So I'm going to come in here. And I'm just going to do that. And then from here, because then I can put a straight line in there. And one thing I like to do when I am drawing curves, and especially when they change either radius or they change direction, is I like to sight down them and look to see that they look fair. And that looks nice. All right. So I'm going to select those edges, and then I'm going to weld those. I have a keyboard shortcut. So you see that now behaves as a single curve. All right. And let's do this. We can get rid of those. Now let's get rid of all the guidelines, and we'll just put back in the ones I need. And I have a keyboard shortcut for edit, delete guides. All right. So in preparation for follow me, I'm just going to draw a circle. Now I'm not going to extrude this shape yet because it's a little easier to use that as a reference while I'm working if it's flat. But I'll select the circle and the profile, and I'll go ahead and make that a component now. And I'll put the yoke tag on it. So I could hide that if I need to. Now, let's look at drawing some cutter shapes for these things and for this yoke. So I want to create a cutout that's got this arc shape. So again, the center of that that's at that 9/32. So I'm going to come down here 9/32. And so my arc, my 3/4 inch radius arc is going to be centered where those guidelines cross. The other thing I know is at 13/16 from the end, that's where this thing here ends up. So if I come down here 13/16, that puts that there. So it's beyond the center of my radius. So I'll show you how we'll deal with that. And there's this funny little radius in here, so we'll get that. So we'll start here. 0.75, and I'm going to come up here. I'll just go make it a quarter circle. And then I'm going to come in here this way. Now those, I just draw those as overruns. It's easier to make sure I get those to intersect where I want them. Just from eyeballing the radius of that, to me it looks like it's about the same radius as the large end of the tapered pin, which it says is 1/8 of an inch. So that should be a 1/16. Whoop. Try again. 1/16. And what I'm going to do to find my intersection is I'm just going to use offset on my radius of my arc here, and we'll come in 1/16. And then I'm going, and this is probably not exactly right, but it works. It'll work well enough for what I'm doing here. So there's my center, and I'll just come around here until that I get that magenta indication. And then I can delete all of that. And I'm going to select all of that, and we will do a copy rotate, and we'll just draw a line. Okay, now I've got a face there, and I'm going to go ahead and weld those edges, and then I'm going to use push-pull and make that thing plenty long. No need to be stingy. So this is going to be a component, cutter 1. Notice it's solid. That's important, or will be later. I'm going to give it the cutter 1 tag, and then I'm going to, well, I'm not going to hide it just yet. Yeah, I can hide it. I don't need it. So we'll get rid of that. And the next thing I'm going to do is create a box to cut through that stuff there. So let's use the rectangle tool. And I'm going to hit Control, the modifier key. Now, let's look over here. This thing is 1 1/4 inches across there. So I want to draw a square that's 1.25, comma 1.25. And you know what I think I'll do is I will move this over, because I think it's going to get in the way. And this will also get made into a component. And we'll call this cutter 2, and I'm going to use them in this order, so that's why I'm doing this. And we'll give it the cutter 2 tag. And if I bring cutter 1 back, you can see they overlap, and that's just fine. And it also overlaps at the end here. That's also just fine. So now I don't need to see cutter 1 or cutter 2. Now, the next one I want to draw is the cutter to create this shape over here on the left. I'm going to draw it in the vertical, or I'm sorry, in the horizontal orientation. Actually, before I do that, I'm going to move this image back over because I mostly want to see the other side of this drawing. All right, and we don't need those guidelines. So I know that it's 1 inch across, so I'm going to need an arc that is has a 1/2 inch radius, and I might as well just draw that as 1. And I do know that the end of this thing, actually we don't even care about that. We'll get that all sorted here in a moment. So, going to draw this straight down a ways, and then we have to look up here at the top. So 23:30 seconds from the center line, and 1 1/8, we need a 1 1/8. So let's do this. 23:30 seconds. Let's try again. 23:30 seconds. And 1 1/8. And I'm going to come out here, and all I have to do is go a little bit beyond my profile. This is kind of why I wanted to keep that profile flat, because it makes it easy to lay this out. Now that and that are going to get copied to there, and then I'm going to come out here and out here somewhere. Doesn't matter too much. This part of it isn't terribly critical. There we go. Now I should have done this before I completed this, but we'll do that. And I'm going to weld those. So that curve acts as one thing. And this, I will go ahead and rotate up to vertical. And then I'm going to push this out so I'm beyond my profile here. So, I don't know, 1.5. 1.5. The only reason I put in the amount there is so I know that I'm going to be beyond the turned profile when I get to that point. All right. So make this cutter 3. Seems like a lot of steps, but if you do this stuff sort of in a methodical way, it's easy to keep track of your dimensions. And so now, even before I go on with the yoke, I'm going to go ahead and draw the ball. So the ball has, or the sphere, has a 3/4 inch radius from the center. So let's do a 3/4 inch radius, and down on here I'll do that, and we'll select this, and we'll run follow me and select all of that, and we'll call it ball. And I'm going to go ahead and give it the tag. And again, I'm looking for solid component when I create these components. All right. And let's do this while we're at it. So I'm going to bring back cutter 2. That's that block. And if I bring back the ball, you can see how the ball sticks out here. That's actually got to get cut off of the ball. So what I'm going to do is I'm going to just draw a rectangle here using my cutter 2 as a reference, and then I'm going to do a rotate copy 180 degrees, select both of those, make those a component, and this ball gets cut only on the sides and the top and the bottom, and they're going to be the same amount cut off, so I'll just do this. Alright, and I'm going to go ahead and cut the ball before I even start actually make the yoke. So I'll bring the ball back, and I'm going to, I've got a keyboard shortcut for this. I'm using an ancient old plugin or extension called Trim and Keep, which works really well. I like it better than the solid tools. You could use Enerot solid tools or Boole tools too instead, but I've got a keyboard shortcut for this, so this is what I'm going to use. So I'll use this to trim that, and this to trim that, and now I'm done with those cutters. So I can just delete those, and I've got this ball with these flats. And it's still a solid component, which is good, and I don't need to see it now. All right, let's make our yoke. So select that, get the follow me tool, run this. It'll take a little time, just a little time because of the number of segments. I'll delete my profile, or my path rather, and let's check it to make sure it's solid. It is. That means I didn't leave any little stray edges. And let's see. You know what I'm going to do? I'm going to bring back, let's do cutter 2 first. So trim, use that to trim that. And I can turn off cutter 2, and you can see I've got that business. Cutter 1, I'll bring that back and trim that and that. And I should have made the pin before I went ahead and did this, and the shaft, but that's okay. We'll add that later. So now you can see that I have this shape here. And now let's bring cutter 3 in. Now here, I know that my arc is a little short. So what I'm going to do, turn this off. I'm going to pull these out. Back. I'll pull those out a bit. I don't know why it does that, but it does. We'll just soften it. And bring our cutter 3 back. Now we're good. And use that to trim that. And turn off cutter 3. So there we have that done. Now I'll cut the holes for the screws in the yoke later. Let's do this. Let's do the shaft. So the shaft has a 1-inch diameter, so there's 0.5, and of course the narrow part is 3/8, and it's got this rounded end, which is a 13/16 radius. It's funny, this center point isn't indicated right at the edge, but it is up here at the top, which is why I marked that one in red. So I'm going to come in there, and let's go ahead and we'll turn off the yoke for a moment. And I don't know, the other end of this shaft isn't, the length isn't terribly critical, but we'll do that. And then I can do from here, 13/16 is the radius, and we'll just come over here till we get to there. And I should, yep, Let's just delete all of that. And we'll go ahead and put in a circle, circle there. And let's look. Very good, there's no hole there. So, if I make that a component, and it's solid, and we'll put a little notch in there just because, or, you know, do that cutoff thing. Let's put a guideline there. And this one isn't critical as far as the radius, but we'll come out here somewhere. Maybe we'll come out a little bit this way. All right. And okay. And we'll make that a component. Check to see that it's solid. It is. This one we will rotate a little bit. How about, I don't know, 15 degrees? Let's go 25 degrees. Doesn't matter that much. All right. Use this to trim that. Done. Perfect. All right. We'll give that the shaft tag, and then turn that off. And let's do this pin. Like I said, I should have done that before I extruded my yoke, but that's okay. We'll manage. So 13/16 up from the back edge of the yoke. Not 13. 3/16. And it says the pin is 1/8 of an inch with a taper of 1/64 of an inch. So we will start here and give it a 1/16 radius, and then I'm going to come out here. Let's see what coming out of 3/4 does. Yeah, that'll work. And then we'll come out this way, 3/4. And now this pin has to have a taper. It's supposed to taper a 1/64 total over its length, so that's not much. Could probably fake it and just leave it alone, but I'm going to do it. So what I'm going to do, I've got the move tool. I'm going to resize this end of the circle, or of the cylinder, using the cardinal point. So what I'm doing is I'm finding a point where the edge of the circle is not highlighted, and I can pull that down. You see how that makes a taper. I only want to go 1/128th, or half of a 1/64, so it's a total of a 1/64 taper. And then I'm going to use the pie tool, and I'm going to, let's hit the up arrow key. I'm going to come around here. And so I've got a round end. I'm going to select, oh, not that. And follow me. And then at the other end, I have the same sort of thing, so we'll do the pie tool again. Now, you see the line that runs along here? What that's done is it's put an internal face in here, and we'll have to deal with that. And that's because this line here and the equivalent one at the other end made a connection there, and so there's a face. No big deal though, because we'll make that a component, tapered pin, and might as well go ahead and give it a tag, but you'll see that it's not solid. Solid Inspector 2 tells me there's an internal face, and you can even see the red line there. I can fix that. It's done. That's solid. I'm going to open this for editing again, and I'm going to just soften, smooth the edges so it's looks like that. All right. So now let's go ahead and we'll cut the holes for that. And then I've got a little work to do yet on the ball, and then we're ready to move on to the screws. So bring the yoke and the shaft back, because they both need the hole. And I'll use the pin to trim the shaft. I'll use the pin to trim the yoke. And now if I turn off the pin, see, we can look right through the two of them. Done. All right, so we might as well make the other half of this joint, then we'll go on to the ball and the screws. So I'll select all of those. I'm going to do a rotate copy, and then I'm going to turn off the copy function and stand this up on the green axis, and we'll rotate it up 90 degrees. If I bring the ball back, you can see everything fits just the way it's supposed to. We're done with our guidelines. Now I'm going to, well, I'll leave the ball, I'll leave the ball for a moment. We'll hide the other elements here. And actually I need to drill 1/4-inch holes, crossing 1/4-inch holes through this ball. So that's 1/8 of an inch. The length here doesn't matter, just as long as it's a solid component when it's done. I'll put a guideline back on there. I wish that the tools would actually snap on the axis lines a little better than they do, but minor deal. All right. Again, I'm going to trim. I'm going to use that to trim that, and that to trim that, and we're done with those. All right, so the ball is done. Now it's time to move on to the screw. So I'm going to draw the screw here, and the screw has the threaded part is 7/16, and it'll be a 7/16 with 14 pitch thread, 14 threads to the inch. It's got a little area that's neck down here and these both are 3/8 of an inch, by the way, that goes into the ball, and it's a 1/4-inch diameter. The head is 9/16 in diameter, and the head is 3/32 thick, and then there's a 1/16 inch counter bore. So let's start by drawing the threads. So I'm going to use the Helix tool from the Curve Maker extension. Click at the origin and drag out here. And I need this to be 7/16, 7/32 for the radius. And from 0 turns to, we'll do 8 turns. It's already set, but it's longer than we need for the screw that we're going to make, but that's fine. The radius, 48 sides per turn, that's good, and I'm looking at the measurements window, by the way. So I think we're good there. All right. So now let's draw the profile of the threads, and I just generally do this way. So I'm going to come up here, come in here. I don't go all the way to the middle. Come back down, because I'm going to need this to be a solid component when I get done. The minor diameter of the threads, I looked up from a chart, and I'm going to draw a line that is 0.0155 long. And I just drew that kind of randomly on that line, but I can grab it at the midpoint now, and I can move it up and down vertically and just bring the cursor over. So it's centered now in that height. And then let's put in a couple of guidelines. So at an angle, 30 degrees, back. Keep that thing aligned. 30 degrees, because now let's take that, we'll do that, and that. There we go. Now I'm going to, I just find this is a little easier to manage this way. I'm going to explode the group for the helix, and I don't need those guidelines anymore. Select that, run follow me. I'm using upright extruder for this. And I should have turned off profiles before I did this in my style. So this will take a little time, but we'll just wait. There it is. That's not bad. All right. So now I don't need that. I'm going to switch the camera to parallel projection and the top view, and just do a little right to left selection box around that center part of it and delete it. Now that, let's go back to perspective just because it's easier to look at. I'm going to select all of that, and then I'm going to use Enerot Auto Weld. And that'll also take a moment, but what that'll let me do is select that edge that's the seam from my profile and delete that. Now we'll go ahead and make this a screw, and then let's do this. I'm going to draw a circle just on the ground plane around the origin. And I know that I need my screw threads to be 3/8 of an inch long. So I'll pull that up 3/8 of an inch. And then I know that my thread pitch is 14 to the inch, and I want to use this middle section of this screw. So what I'm going to do is just grab this someplace, doesn't even matter where. I'm going to just move it vertically in the blue axis. I'm going to go down 2/14. 1/4. Whoops, 1/14. Is that all right? Yeah, we'll go down 1/4. That's fine. All right. I don't need the cylinder or the side of the cylinder. I need the top and bottom is really all I wanted out of that. And I'm going to use the keyboard shortcut to cut that to the clipboard, open that for editing. I have a keyboard shortcut for paste in place. Back to camera, parallel projection, front view, turn on my hidden geometry, and I'm just going to do a right to left selection box that kind of encompasses the geometry around the plane of that circle. And you see it's only selected some of the faces here. It hasn't selected all of these. I do this way so that SketchUp doesn't have to look through every single face in the component to do the intersection. And I'll repeat that down here. So right to left, just around, kind of keep it narrow. And there are a few extra faces, but it's not that many, and as you can see, the intersection goes quite quickly. Let's turn off our hidden geometry and select those. And now, because I had run auto weld all of those edges were selected, and you can see I have a face now there. And we'll do the same thing here. And so let's get that eraser. And we'll go up here. And there we go. And if we're lucky, or good, we live right, there's a solid component. Perfect. All right. So let's do the little stud on the bottom, or the neck down bit on the bottom. So I'm going to do that outside of the component. So that's 1/8. And I'm going to come down here 3/8. And I'm going to put a radius on the end of this. And if we look at the drawing, it shows the end of the screw still being flat. So that radius is something less than, I don't know what it is, but something less than making that a hemisphere. So let's use Freddo corner. I'm going to make that, I don't know, 1/16. Let's look at that. Yeah, that'll work. Perfect. Now I could make this a component and then use a unioning tool to combine these, but I think it's actually faster just to select all of that. Actually, let's do a cut, open this for editing, paste in place, and then I'm going to hide the top surface so I can get in there and delete the internal face. I could have let Solid Inspector 2 do that, but I didn't. All right, so let's edit, unhide last, and again, that's still solid. We can go back to perspective here. So now, refresh my memory, 9/16 is the diameter of, I'm going to put a thing in here, 9/16, so 9/32 is the radius, and it's 3/32 for the head height. And let's see, we will add that to the screw. So I'm going to do a cut, paste in place. Let's look, reverse that face. I don't know why it does that, but we can fix it. Hide that one, delete that one, edit, unhide last. We'll check to see that it's still solid. It is. We'll open that for editing, and I'm going to outline the slot, but I'm not actually going to cut it yet. So Control, so I'm drawing from the center, and let's make that slot, I don't know. We'll look at the dimensions here. I'm just going to type comma 1/16 because it's long enough. I didn't need to enter the the longer dimension because I didn't even care what it was as long as it was longer than that. The reason I'm not cutting that is because I'm going to use this screw to trim or to create the threaded hole. It's not technically right for the threaded hole in the yoke, but it'll also create the counter bore. And if I put the slot in, then that'll screw up my counter bore, so I don't want to do that. Now, what I know here is that the outside radius of the yoke is 1 1/16 from that 2 1/8 over for the diameter or the total width, and the counter bore is 1/16 deep, so that means I need the bottom of the head to be 1 inch up. So what I'm going to do is I'm going to move this down, and since it's just easy, I'm going to use a square bracket, comma, comma, 0, and hit enter, and that just, it didn't change the X or Y positions. It just set the point that I had grabbed to 0. And then I'm going to move it up in the blue direction, 1 inch. And while I'm here, I need 4 of these screws, so let's do this. We will, actually before I do that, because it's a lot easier to do it this way, with only 1, let's give it a tag. And now we will do 90 times 3. All right. I'm going to make another edit to the screw also in a moment, but I want to do this part first. So let's turn on the yokes. And doesn't matter which one of these I attack, but I'll use this one here. So I'm going to use my trim tool again, and I'll use this screw to trim the yoke, and that screw to trim the yoke. And because they're all components, if I turn off the screws, you can see I've got threaded holes and counter bores all the way around. So now I don't need the yoke, but I need the screws again, because I don't like the way the threads end here. So I don't know if that's really an important thing or not, but I'm going to deal with that. So I'm going to draw a cutter, and let's go out here. So we'll come out here about 0.1375. Yeah, that's good. And I'm going to draw up. Finish that. Okay, and then I'm going to, so I just set that angle at 30 degrees because it matches the angle on the screw threads. I'm going to move this up to this point here. That's where I'm going to cut this off, at least initially, and we'll look at it and see what we think. And I need a follow me circle, and we'll make that a solid. And you see I left a hole in it because I don't want to touch this little, I don't know what you call that, the narrow part of that. And the beauty of using Enerot solid tools or Boole tools or the trim and keep is because it respects the components. I can see, when I trim this, I can see what happens on the next screw, or actually on all of these, but so I don't have to worry about seeing it or getting rid of it. So I'm going to use that to trim that. And you see it's done it. Do I like that? Yeah, I guess that'll work. All right. So I'm done with that. And let's do this because I don't like seeing that. I'm going to just go ahead and soften that edge. Oop, and there's a little tiny bit up there. That's all right. Not a big deal, but that just kind of finishes that screw. I really should probably do something up there under the head because you couldn't just run the threads out like that, but I'm going to leave that one alone. We'll delete that. And my trim, I'm going to undo the trim here. One of the things that it did is it deleted my coplanar edges. So I'm going to go ahead and open this for editing. Undo is your friend. 3/64. We'll make it about half that deep. Okay. Now, trim the screw. Delete that. Control Z is probably the most important keyboard shortcut. Come on, there you go. All right, so, and just one thing, I didn't really stress this before. Actually, before I do this, I'm going to turn on my cutters. I don't need those anymore. I'm happy with what I ended up with, so we'll delete those. Turn on the ball. The screw, the shoulder on the screw ends just at the ball. Turn on all of our parts. We don't need the image anymore, so we'll get rid of that. Let's switch to X-ray. You can see everything is there and it's all in place. So one of the things I did here was I drew everything exactly where it was going to live when I was finished with it. So no, other than the screw, and the only reason it was drawn the way it was is because that particular extension likes to start. It's happiest if you start at the origin. So, but that also gave me a good reference for some of the other stuff that I did to that. So, if I select all of these things, you can see I've got 11 solid components. Everything's solid, everything. So that means everything's clean. And now I'm going to run TIG's purge unused and get rid of all of the excess components. One of the things that trim and keep does is it leaves the original component that it modified, which can be handy if you need to go back, but that's that. Now it's all done. Hopefully there was something there for you.